whatever the problem is. I'm amazed by it. I don't understand it, but I have to admit that although I am an instrumental physicist, my skill set is in measurements with all kinds of instruments. I have to admit that the human body is one very sophisticated biological transducer, and it's capable of detecting all kinds of things that we just do not generally accept yet.
Well,
I agree.
I'm just going to mention that Dr. Shafika Karagula has written a book about, she was a medical doctor, but she could diagnose the people when they came into her office, but she would have tests run just to back it up.
Sure.
And after she wrote the book, she heard from a lot of doctors who said they do it too. They
Right.
could tell what was wrong, and if it works, use it, is my feeling.
Well, that's kind of what draws them to the science, too, and then they have to learn the medicine behind it, but that's what draws them to it. They have an affinity for it. They have this natural ability.
Well, the British learned to feed their sailors on the high seas limes. That's why they call them limey. It was a long time before they realized it was vitamin C. It hadn't been discovered at the time. The same thing happened with treating pernicious anemia, which was invariably fatal, but in the 20s they could create the condition in dogs and feed them all kinds of stuff and see what worked and what didn't, and they found that feeding them liver would cure the problem. Now, it was many years before they found out that it was what it was in the liver. And we're talking about vitamin B12, and we're talking, minuscule amounts, micrograms. So
the Romans used to put silver coins in their water drums to keep bacteria from growing in them.
Huh. Well, there's a guy in our book who wrote a book about the body electric, a man named Becker, who did a lot of work with silver, various silver compounds as treatments for disease. And he also found that he could, crazy as it sounds, use electrical devices to cause mending of broken bones, which otherwise didn't mend. Most bones do heal, but in ones that don't, if you put the right current in the right place at the right strength, you could induce healing.
Absolutely.
Why is it that what are these critters that you can cut off a limb and they grow a salamander?
Salamander.
Yeah. How the heck does that happen? So, and he found again that electrical stuff, appropriately used, would enhance the process. Now, some of this sounds crazy, but the experimentalist says, well, let's see. I can see a possible reason for this happening, and maybe it turns out to be the wrong one, but it's what happens that matters. And that's the thing, that we are still ignorant.
Well,
I mean,
we know. We're not stupid, we're ignorant. We just don't know. We've danced around this subject all night long, and it's kind of the granddaddy of them all. More than half the world knows they exist. There are so many pictures and measurements that they exist that only a fool would doubt their existence. And yet, scientific groups like Caltech and NASA deny they ever existed. And certainly, they do not exist today. And I'm talking about UFOs. In your book, you have this marvelous statement. I've got to quote it. It says, in summary, there is an enormous amount of information indicating that Earth is being visited by advanced alien spacecraft, despite vociferous claims to the contrary by the educated individuals who have not reviewed the evidence. Science is wrong again, isn't it?
Yes, and it's an area, of course, close to my heart. I've only lectured at more than 600 colleges in 100 professional groups in all 50 states, 9 provinces, and 16 other countries. So I've had plenty of opportunity to see what the reaction is. My lecture is usually flying saucers R, underlined, capitalized, real, exclamation point. And incidentally, I better add, it's not just me talking. I've only had 11 hecklers in all those.
Oh, my goodness. Well, that's good.
And, you get that many if you were talking about sports, religion, politics, so I'm told anyway. But, yeah, we have a strange situation here. Most people think they're real, but most people think, as I said earlier, that other people don't think they're real, so they better not speak out. And what bothers me is the bad science used by the nasty, noisy negativists, the people who tell you there is no evidence. And you keep looking for the references. Well, I don't see any mention of any of those 5 large-scale scientific studies I talk about. What's the basis for your views? They don't have any. They just know it can't be.
Yeah, I have a lot of friends that are astronomers, and when we go out to dark sky events, they say, "Okay, now listen, no talk of UFOs out here. Okay, we're looking at stars. Anything you see flying overhead is a satellite. So shut the heck up." Come on, for crying out loud. One of the biggest areas of denial is, they say, it's impossible to travel at the speed of light, and even if it was, it would take 100,000 years to cross the Milky Way alone. So star travel is not feasible.
Yeah, that's one of those things where you listen and you say, look at what you just said. Yes, let's assume that it's true that the galaxy is 100,000 light years across. But what has that got to do with the question of whether we're being visited? There's 2,000 stars, roughly, within 55 light years of the Earth, and 8 times that many within 100 light years of the Earth. Why would anybody in his right mind worry about, gee, I can't get to the other side of the galaxy? Who cares? If I need a loaf of bread, I don't say, gee, that bakery in Australia is great, but I can't get there and back in time for dinner. My wife would say, hey, the superstore is a mile and a half away, and we need it for dinner tonight, not next week. Don't go to Australia. And one of the things that is really astonishing to me is that astronomers, who very well know that nuclear fusion is what produces the energy of the universe, if you will, can't imagine that anybody could use that for propulsion. I worked on fusion propulsion systems, studies of them, back in the early 60s, for goodness sakes. If you use the right stuff in the right way and kick particles out the back end that have 10 million times as much energy per particle as they can get in a dumb old chemical rocket. I don't use a slide rule anymore. Why would you determine how many calculations you can make per year using a slide rule instead of a computer? Well, why would you talk about chemical rockets to get to the stars? And why would you look at distant stars as opposed? I had one guy, an astronomer, say, but Andromeda is an awful long ways away. Think of how much energy it would take. It's 2 million light years away. Who cares?
Exactly. With the ion drives that you're talking about, we could accelerate at half to 1 G for a few months, and then decelerate at about that same amount, and we'd be there.
Well, I use the example in the book of Dr. Campbell, an astronomer who in 1941 was sick and tired of all this science fiction stuff about sending a man to the moon. And he set out to write a professional scientific paper loaded with equations in which he would show what the required initial launch weight to do that was. That's a good question. How big is the thing going to be? That's a reasonable question. So he did that. He published the paper, and the bottom line is the rocket would have to weigh 1 million tons.
Wow.
Tons. Now, the only trouble is he made every possible wrong assumption. For example, he assumed a limit of 1G acceleration. The astronauts routinely take 5. He assumed a single-stage rocket. Bad advice. He assumed the only way you could slow down when you get back is a retro rocket, which, of course, you have to lift from the Earth, slow down at the moon, lift from the moon, slow down back here. He also, and we don't do that. We use the atmosphere. You know, we don't need to put it there. Kind of nice. I call it cosmic freeloading. Take advantage of Mother Nature. We also launch to the east from near the equator. There's a 3,000 miles an hour. And when we go to the moon, there's a launch window, a certain period of time where you want to launch in that period of time. Why is that? What difference does it make? Well, it makes a heck of a difference because you want to use the moon's gravitational field.
Right.
If you launch at the right time, the moon will come along and do its thing. You don't need to do anything about it. Be in the right place at the right time. It's a freebie. Also, you know, let's look at the bottom line on this. We got 3 guys to the moon and back. The initial launch weight of this dumb old chemical rocket was a big one, was 3,000 tons. Dr. Campbell was off by a factor of 300 million. I mean, that's a good-sized mistake, I'd say. Not 3 million, 300 million. And so if you make enough wrong assumptions about doing anything, one of them is space travel. Incidentally, I try a little experiment. Sometimes on campus, I get informed by the students that the professor was going to try to make an example of me in a little seminar in the afternoon, show how stupid this guy who says flying saucers are real is. So I make sure that I talk about things that I know they don't know anything about. Well, you know, you're all familiar with that, I'll say, and no hands go up. You know, and after I've done that a few times, they realize that maybe their professors aren't as smart as they think they are. But then I play a little game. I'll say, what's the value of 1g, the numerical value of the acceleration of gravity at the surface of
32 feet per second per second.
They automatically say 9.8 meters per second squared. And I say, yeah, that's right, but how do you relate that to the real world, like Corvettes? And they look at me like I'm talking Swahili. I mean, you know, you mean you're supposed to relate this to the real world? Yeah. To give you numbers, 1g acceleration is 21 miles per hour per second. So if you accelerate at 1g for 3 seconds, you'd be going 63 miles an hour. And that's a pretty hot car. Most cars take 4, 5, 6 seconds to get 63 miles an hour. Okay, then I say, what's the speed of light? 300,000 kilometers per second. They're going to show how smart they are. I say, yeah, that's true, but how do you relate that to the real world? 670 million miles an hour. And that's meaningful because the Jupiter and Saturn are a few 100 million miles away, so that gives you a scaling factor. I said, but the real question is, how long does it take at 1g to get to the speed of light? And you don't need to do any calculating. It's a multiple choice question. 1,000 years, 100 years, 10 years, 1 year.
1.
And I'll ask how many think it's 1,000, how many think it's 100, et cetera. You'd be amazed at how many think it's 1,000 or 100 or 10. The answer is 1 year. 1. Single. Uno. But they don't know about it. They're not concerned with the real world. And they also, isn't it amazing how people want to use half an Einstein? You know, you can't go faster than the speed of light. Oh, but we're not going to talk about the fact that you get closer to the speed of light, time slows down for the things moving that fast. At 99.99% of the speed of light, you can go 37 light years in 6 months pilot time. And we Earthlings know a little about things going close to the speed of light. Mother Nature provides. But that big collider over in Europe there, 99.999, I think there's another 9 in there someplace, percent of the speed of light. So it's not out of the question. But they don't want to talk about that. And it's incredible to me that people who consider themselves scientists refuse to do their homework about interstellar travel. And there is an intermediate step between chemical rockets, Saturn V rocket, and nuclear fusion. There's nuclear fission. I worked on fission rockets. We built them. We tested them. Los Alamos built the biggest one, less than 7 feet in diameter. The power level was 4,400 megawatts. That's twice the power of Grand Coulee Dam.